Okay, today we're continuing chapter 3 with inequalities in one variable, and this is section 3.2 on compound inequalities. So compound inequalities, well, when there's several inequalities that are combined together, we can either combine them with and, or, or what we looked at last time, which is the tripartite, and that's kind of like an and. So that's going to be similar to how the and works. So what we're going to do is we're going to let A and B be sets, and the union of two sets contain all the elements contained in either set or both sets. So it can be in set A, or in set B, or in both set A and B. And union is denoted with the A with the kind of the U-shaped thing, and then a B. So that's A or B, or A union B. Then we have the intersection of two sets, and that contains only the elements that are in both sets. And so this is notated as the intersection looks like the upside down U. And so that's going to be A intersect or A and B. Okay, so that's going to be how that looks like. Now with compound inequalities with the or. Now this is the union inequality, so the solution is what is true for one inequality, the other inequality, or both. And so what we're going to do is we're going to graph both inequalities, and then we're going to determine the solutions because it's going to be all the points in the graph for the solution. And your interval notation is going to usually contain something where you have a union here. And so you're going to have something maybe like from negative infinity to 4 union, and then maybe 5 to 8, and then union, I don't know, 9 to positive infinity. Maybe you have all those pieces, okay? And so sometimes you might only have 2, sometimes 3. It can vary, but that's how you're going to write it out. Now, if we have a compound inequality with and, this is the intersection inequality. So the solution is true statement for both. So basically, wherever the two solutions intersect is going to be our solution, and it's going to be a single interval. And so, kind of like we saw in the tripartite, one might go this direction, the other one might go this direction, and the intersection is the only part that counts. And so it's going to go, go from here to here, and that's going to be our solution. And so we'll just have one interval when we get done as far as writing in interval notation, whereas this one we had multiple pieces because you might have had a graph that went from like this it went like this to that, and then maybe from this to this, and then from this to that. So you might have had something like that to represent this one here, where this is the 4, this is the 5, this is the 8, and this is our 9. Okay, again, not drawn to scale with the intervals, but just in rough estimation and in respect of how they should be. So that's kind of how the graphs are going to look different, and then our interval notations are going to look different. And so now what we're going to do basically is we're going to solve our compound inequalities. We're going to graph the solutions, and from that graph, we're going to write the solution in interval notation. All right, so with or, remember, that's going to be both. It's going to be in this one, or both. And so what we have to do is we have to solve both of these. So we'll first subtract 7. And so we get x is greater than or equal to 12 minus 7 is 5. Or, now this one, we have to solve for x again, but this time we're going to divide by 9. And so this is going to say x is less than, here it looks like a negative 5. So we're going to have a positive 5 over here. We're going to have a negative 5 over here. So it's going to be less than a negative 5. So that's an open circle going that direction. And greater than or equal to positive 5. So that's going to be a closed circle going that direction. And so our solution is going to be what's in this one, or both. And so we're going to go from negative infinity to negative 5. That's going to be a parenthesis because it's open. Then we have union. Now we're going to have from here, that's going to be a bracket, and it's going to go from 5 to positive infinity, and then in parentheses. Okay, so that's going to represent our solution. And again, because they have or, that's the union, and so we're going to have a union here. All right, so this one is and. Remember, that's the intersection, so it has to include stuff that's in both of them, not just parts of it. And so in this case, if this was the intersection, there's nothing intersecting, so this would be no solution, but it was or, so we had both pieces. Now this one, what we have to do is the same thing. We have to solve both of these inequalities for the variable. So first we'll subtract 10. So a is going to be greater than or equal to a negative 7. And now here we have to divide by 8. A is going to be less than or equal to 48 divided by 8 is 6. So now we draw that out. So here, let's call that a 6. Here, let's call that a negative 7. So it's going to be greater than or equal to a negative 7. So we're going to have greater than or equal to, so it's going to go that direction. Here, a is less than or equal to 6. So it's going to be closed circle here, everything that direction. And our intersection, because it's and, is where it actually is. And so it's going to be from a negative 7 to the negative 6. So that's going to be what our graph of this solution is, because it's only the intersection part. And so now we have negative 7 up to positive 6, and that would be our single interval notation for the solution. So we don't use anything out here or anything out here. We just use parts where they intersect each other for the and. Okay. All right, so this is the tripartite. I don't know, this might even be one we used last time. It kind of looks familiar. And what we have to do is we have to solve for that k. So we need to subtract 8. And whatever we do on one part, we have to do on all three pieces, remember. And so 11 minus 8 is 3, less than k, less than or equal to 4. So again, if we do this, k is, well, let's go ahead and put our 3 and our 4 in here. So k greater than 3. So that's an open circle going to the right. Here, k is less than or equal to 4. So closed circle going left. And our intersection is right there. And so it's going to go from a 3 to the 4. And so from interval notation, we can write that directly below. That's going to be a parenthesis, 3, comma, 4, and then a bracket because of the closed circle. Okay, so this is, like I said, this is like the and because you have to have that intersection part is where it is true. All right, here we have and. So again, it's going to be where they intersect. So it's going to look like that one. So what we have to do is we have to solve both of these inequalities. And how do we do that? Well, let's see here. I think if we take the v's to the left and the numbers to the right, that'll be the best way, because then we'll end up with positives. So add 8v here, we'll add 8v here. Here, let's get rid of that by adding 8. So those cancel. We have 8 minus 6, so that's a 2v, less than or equal to. 8 plus 8 is 16. Those cancel. Now we have to divide by 2. So v is less than or equal to 8. And then we have and. Now here we have to solve this one. Now here there's more v's than there are here, so I'm going to subtract 7v here. I'm going to subtract 7v here. So again, whatever you do to one side, you have to do the other. And here I'm going to subtract 6. I'm going to subtract 6. So now I have this v's gone here, and I have the 6's gone here. So I have 9 minus 6 is 3. And then it's less than or equal to 10 minus 7, that's 3v. Now I divide by 3 on both sides, and 1 is less than or equal to v. All right, so now what I'm going to do is plot each of the inequalities on here, and wherever the intersection is going to be our solution. So we have a 1 and we have an 8. So v is less than or equal to 8. So less than or equal to is closed circle to the left. Here v is greater than or equal to 1. So greater than or equal to 1 means we're going to go everything that direction. And because it's the intersection, where is the intersection? Well, that's right there to right there. And so it's going from basically the 1 to the 8. And so that would be kind of our graph. And so it's going to be a bracket 1 comma 8 and in bracket. And so that would be our interval notation for that graph for these two inequalities that we've solved with the and. All right. Now we've got or. So remember, or is the union. So it's going to be either in this one, or it's going to be in this one, or it's going to be in both. All right. So first we have to solve this one. Well, to get r by itself, we have to divide by 10. Well, when you divide by 10, we still just get 0. So r is going to be greater than 0. Or, now let's add 5 to both sides. R is going to be less than, now minus 12 plus 5 is going to give us a minus 7. So here we have a 0, here we have a minus 7. So r greater than 0, well, it's going to be open circle going that direction. Here r is less than a negative 7, so it's going to be open circle going that direction. Now remember, or it's just going to be everything that's on that line up here that we show. So it's going to go from negative infinity to negative 7, parenthesis, union, parenthesis, because we have an open circle here, 0 to our positive infinity. So from 0 all the way up. And so that would be our interval notation with the or, because remember, or is our union. All right, so this one, it looks like we have or again, so we have another union. Okay. Now we have to think about this. Well, I think there's more negatives here than here. So if I take and add 9m to both sides, that's going to give me a positive m's. So that means I'll have to add 10 to get rid of it there. So when I do that, those cancel. So 10 plus 2 is 12, less than 9 minus 6 is 3m. And we still have our or. So now we divide by 3, and 12 divided by 3 is 4, is less than m. Okay. Now here, we have a positive here, and there's a negative here. So let's add m to both sides. And here we have to subtract 10. So that's gone, that's gone. We have 5 minus 10, so it's a minus 5 is greater than or equal to 4 plus 1 is 5m. Now we'll divide by 5. So we have a negative 1 is greater than or equal to m. And again, you know, we have this or still. So let's plot this. And so we're going to have a negative 1, and we're going to have a positive 4. And so m is greater than 4. So again, we don't have a closed circle. We have an open circle going to the right. Now here m is less than or equal to a negative 1. So that's a closed circle and going to the left. Okay. Now the union includes both pieces, and so it's going to go from negative infinity to negative 1. That's a bracket. Union, now that's an open circle, so that's a parenthesis, then 4 to positive infinity. And so that then would be our interval notation for the graph that we show here. All right, a couple more ands. We have the typical one where it's ands spelled out, and then we have the tripartite, which is the given, it's an and statement. All right, so here we have to solve both of these inequalities. So here I'm going to first say, well, let's subtract 2x from both sides. That'll still give me a positive. And that means we have to get rid of the 1 there. So the 1's cancel, the 2x's cancel. 9 minus 1, that's 8, is greater than or equal to 10 minus 2 is 8x. Now we divide by 8. And so 1 is greater than or equal to x. And we still have and. Now here the 7's larger than 3, so let's subtract 3x from both sides. Now that means we're going to subtract 2 there. So the 3x's cancel, the 2's cancel. Minus 2 is going to be minus 4 is less than, here we have 7 minus 3 is 4x. Now I'll solve that. We have 4 divided by 4 is 1, so we have a negative 1 less than x. All right, so let's plot those. And again, this is going to be the intersection when we have and, so that's what we need to have as intersection. So here we have a negative 1, here we have the positive 1, so x is going to be less than or equal to a positive 1. So we have a closed circle going to the left. And here it says x is greater than a negative 1, so it's going to be an open circle going to the right. Now that's intersection is from there to there. And so we have open circle to That's a closed circle. And if you have an open circle, it's going to always be an open circle no matter what. So that'll stay an open circle. And so that says from -1 to 1 and then bracket. So parenthesis, then bracket. Okay. Now this one again is going to give us a single interval. And so what we do is, well, we need to solve for n. So let's get rid of that 10. So we have to add that to all places. And so -16 plus 10 is a -6, less than or equal to 2n, because that 10 cancels. And 22 plus 10 is going to be 32. Now we divide by 2, divide by 2, divide by 2. So here we have a -3 less than or equal to n, less than or equal to 16. All right, so now let's see what it looks like graphically. So we have 16 over here, and we have a -3 over here. So n is greater than or equal to a -3. So greater than or equal to -3. And here it says n is less than or equal to 16. So less than or equal to goes that direction. And our intersection is at that point. So it's going to go from -3 to 16. Both of them are closed circles. So we'll have a bracket, -3, +16, bracket. Okay. And we have one last one here we're going to work on, and it's another tripartite, so it's another and it's just going to be similar to the last one. We're going to, get rid of that 9, and then we'll have to divide by 3. So let's add 9 at both sides, or all 3 sides, I should say. And so what do we have here? Looks like a -15 greater than or equal to 3n greater than or equal to 42. Okay, now we divide by 3, divide by 3, and divide by 3. -15 divided by 3 is a -5. That's greater than or equal to our n. That's greater than or equal to, 3 goes in there, 1, 4. Okay. All right, so now we can plot that. So here we have our 14. Here we have our -5. So here it says n is greater than or equal to 14. So it's going to go that way. Here it says n is less than or equal to a -5. So we'll have the closed circle going that way. And remember, this is the intersection. Where do they intersect? They don't. So in this case, we have no solution or the empty set. Okay, so hopefully that'll help you get through this next section.